Hello and welcome to SMARS Fam. I'm your host Kevin McAleer, and today we'll be looking at programming SMARS with the Arduino IDE and looking at sensors, specifically the rangefinder sensor. So SMARS, for people who are not familiar with this, watching on YouTube, it's an amazing low-cost open source 3D printable robot. It's very easy to print yourself and assemble, very little electronics or programming skills required, and the purpose of these sessions is to sort of enhance people's experience of SMARS. Okay, so let me just move across to here. So I've got a little preamble I just want to do just before we get into the code itself. So it's all about the rangefinders. So let me just start this little video that we've got on here first. So you can see there we've got a SMARS 30 centimeters away from an object. It sends out a ping, and the ping hits the object and bounces back to the SMARS robot. And what we've got on screen there is the actual formula and the sort of physics of what's going on with that sensor. So it's sending out a sound wave at the speed of sound, which is 3,440 centimeters per second, or 344 meters per second. And what's happening there is the sound wave is travelling at that speed, it's hitting the object and then bouncing back to the SMARS. So what we can use is a little bit of math there to figure out how far away an object is. So what we do there, we can see that the sound wave has bounced, it's hit the object and it's come back. So if we halve the speed, that's the first thing we need to do, because it's bouncing there and back, so the distance of the wave is actually double what we want. And what we're getting there is 8.882 milliseconds as the time it takes to send the signal out and bounce it back off the object. Therefore, if we then look at that in centimeters, so we have to just times it by 1,000 to get the number of centimeters travelled in the time, and times it by the speed of sound, and we can actually see there that we get pretty much, 30 centimeters as the answer. So if we take more than one reading, we'll get quite a few accurate responses about exactly how far away these objects are. The objects do need to be able to bounce the sound signal back to the SMARS sensor, to the rangefinder. So soft furnishings or anything that's an angle might detract from that nice flat sound wave bouncing and hitting the object and coming back. Okay, so move on to the next slide there. So what we're getting into now then, if we've got a sensor that we can detect distances, we need to think about obstacle avoidance and algorithms and choices that we have when we're looking at avoiding obstacles, because there's more than one way to do this. And one of the things I was looking at when I was looking into this about how best to explain this, you can see today I've got my PacMan t-shirt on there. So yeah, I was looking at the PacMan. If you think about the arcades in the 1980s, they didn't have very much memory, and very similar to the Arduino that's in the SMARS. They were 8-bit machines, they didn't have very much room for code, so everything had to be quite efficient. But one of the interesting things about PacMan is that each of the 4 different ghosts that are the enemies on PacMan have different personalities or different algorithms. And what I find quite interesting is that makes the game a lot more interesting, because they're not all just using exactly the same code to move around. So Blinky, who's the red ghost, he's the chaser. So what he'll do is he'll move towards PacMan's current position, and it'll just look at the number of tiles, distance, either top to bottom or left and right, and then move towards that when it's making a decision what direction it can go in, which is quite obvious as a strategy. Now Pinky is a bit more devious. What she will do is she'll look 4 moves ahead of PacMan's current position and location and target that. So that's a lot more strategic. So rather than going to where PacMan is, it's where he will be. Inky, the blue ghost, he's more bashful. What he does is he looks at the red ghost's position and direction when targeting, and he does something similar, so sort of have a pincer movement. And then finally Clyde, he kind of does his own thing really. He's just a bit of a wild card in there, so he's not really that interested in targeting unless PacMan is very close. And I believe there is actually a bug in the original arcade of PacMan to do with Pinky, and if he's travelling, if you travel directly at him or her, it will cause an overflow, and that means that there's a bug, and it will immediately turn around and go back off in the other direction. No doubt they've actually fixed that bug now, so I don't know if that's still a strategy that you can use, but yeah, the point here is that you can use some quite simple algorithms to produce complex behaviours. So I was thinking about that when we were putting together the code for our rangefinder and our obstacle avoidance. So let's move on to the next bit, and what I've just shown there at the very bottom of that was the link to the article that I was reading about this in game internals. So understanding the PacMan ghost behaviour is well worth a read. I'll put a link in the show notes. So SMARS obstacle avoidance. So if we think about how we can do this, we can just make it roam around, so essentially just move forward. The next thing, if the sensor starts to detect that there's an object within range, and we can decide what that is, so I've said it's within X range, maybe that's 10 centimeters, we can get it to slow down perhaps. If it's within Y range, so maybe it's like 5 centimeters in front of the SMARS, maybe we want it to stop, turn around, and then measure again to see is there another object, and then loop around and do that same code until it's got a clear path. Once it has got a clear path, we want it then to go forward and continue its roaming mode. Now there is some alternatives to that. We could look at an edge hug sort of algorithm where rather than turning left or right, there's always a particular preference that it has. Like if it always turns to the right, then it will enable it to sort of hug round an object. So if you've got a wall that sort of bends round, if it's always turning to the right, it will actually hug that edge. So that's one way. If you had a maze and you had some SMARS robots in a maze, you could get them to sort of exit the maze by always having this turning to the right. That's one algorithm. We could have another one where in the roaming mode, rather than just going straight forward, after a certain time it just picks a random direction left or right and then goes from there. So there are a few different obstacle avoidance things we can have, and our aim is to make sure our SMARS can navigate a room without hitting any objects, and do that using its own logic without any kind of remote control for this code. So here's a few scenarios. So straightforward one is it's going directly to a wall and it's quite straight on, quite planar to that. It will then get to a certain distance. In this case it's doing a left turn and then it's continuing on its way. So that's a nice simple scenario. And then another one is if there's a corner, you know, how does that work? So it's going to measure that, it's going to measure it again and go, yep, still not clear, and then it's going to go straight on. And then the edge one that we talked about before, so on this scenario it's on the left hand side, so if we preferred to hug the left and always turn to the left, we could perhaps move around. So there's a few different scenarios and a few different algorithms that we could look at implementing. So let's look at our SMARS cam. We've got him set up here. We've got an auto DIY just peeping behind the back there. There he is. And at the moment this is just running the blink code. You might be able to just see the light in there just flashing on and off every second. So nothing interesting that's going on there. We've got the Raspberry Pi again set up, ready to go. So let's go full screen into that. Okay, so what I'll be doing is I'll be following along with the tutorial, the lesson on the SMARS website. I just jump back to that for a second. So if I bring this code down here, so this is the SMARS website, and in the play section there is a few lessons. I've rejigged this recently, so there's a little bit more in the other lessons. We've got lesson 1, which was about movement, just moving forwards. In the previous live stream we kind of did lesson 1 and lesson 2. I'll put a link up in the cards to that video. And this is about lesson 3. So lesson 3, if we jump to that, is all about distancing and ultrasonic sensors and then making an avoidance algorithm. So that's what I'll be following through here. We've got some example code that I've put together, and let's make a start. So let's jump over to the Raspberry Pi. Okay, so the first thing I'm going to do is just save out this new sketch. We'll call it something like rangefinder. So this first program will simply be just to detect distances from the rangefinder. It won't do anything from the robot's point of view at all. It'll simply just be detecting distances. Okay, let me just bring up my code on the other screen. Okay, let's crack on. So the first thing we want to do is set up some pins so that we can actually talk to the rangefinder. So the echo pin is on pin 8, and we'll define another one which is the trigger pin, and that's on 7. So if we just look at our this shield that I've got on here, this is a Fujimoto shield, and it actually has a little plug-in area there for some pins and a header conveniently for the rangefinder, and that's what them pins there 8 and 7 respond to. But you can choose to do them on any pins you like. I think the Fujimoto is one of the shields that has that. The standard Arduino motor shield I don't think has that built in, so that's why we've chosen them pins there. Okay, so next what we want to do is just set 2 other variables. So set the variables for ping duration and measure distance. So this is just a comment to remind us what this is about. So we've got the duration, which is a long, and we have distance, which is an integer. So again, just to go over what these things are, the echo pin is the input. That's kind of like the microphone for the rangefinder, whereas the trigger pin is like the speaker. That's the thing that's going to fire out the wave. It's just going to do a noise, essentially. It would create a waveform in front of the SMARS, and the microphone will listen to that. So that's exactly what those 2 pins are for, the speaker and a microphone, but we call them trigger and echo because of the speed which is involved in it. Okay, so that's the 2 things there. In our setup code, we need to set up them pins, so we need to say pin mode for the trigger, which again is our sort of speaker, so that's going to be an output. And the echo pin, which is that sort of our microphone, which is going to be an input, not surprisingly. Okay, and we'll also set up the serial with a baud rate of 9600, and when we get onto the video about communications and serial comms, we'll talk a bit more about things like baud rates and so on, and ASCII characters, but for this one we just know that that's the thing that we need to type in. So we'll do print line, and this is I'm going to say ultrasonic sensor. HC-SR07. Just need to close the speech marks there, and then the last line there is print line. And this is going to be with Arduino Uno. Version 3. Okay, so just very quickly about the long and the int. If you're familiar with variables, you can skip over this little bit here, but a long is essentially a very long number. I think it's about 4 bytes worth of numbers, so that means we can store quite a long number in that. It's in the sort of millions rather than the sort of 255 that you can fit in a byte in an int. Well, in an int you can actually store, an integer is 2 bytes, so you can store up to 65,000 or minus 32,000 to plus 32,000 if it's a signed integer, if you want to use a signed integer. So these 2 things, the duration, because it's it could be quite a long time for the sound wave to come back. It's more than what we could store in an integer. That's why they've just chosen long, but that's what that's all about. Okay, so the next bit then is our loop. So this is where the interesting stuff happens. So what we're going to do first of all is a digital write, and this is to the trigger pin, and we're going to set that to low to begin with, and that's essentially going to clear whatever state it was in. We're going to put it in low, and therefore we know that it's sort of switched off and it's not going to interfere with anything. We're then going to delay for some microseconds. Let's move my thing out of the way. Microseconds, and we're going to delay for 2 microseconds. That's a very short amount of time, but it's enough to send the signal to say switch this off and have the device respond. Then we're going to do another digital write, and we're going to, again, to the trigger pin. Remember, our trigger is our output, it's like our speaker, so we're going to say high. So unlike a speaker where you can have different frequencies, with these devices it's essentially on or off, so we don't really care what frequency is, we just know that these two things are paired together and that they work fine, so this is why it's just kind of on or off, high or low. So we're going to do that, we're going to say set to high. I'm just going to put a comment just in between those two bits there because this is a sort of slightly different set of code. So this sets the trig pin high, which is kind of active, for 10 microseconds. Okay, so we need to wait then for 10 microseconds. Which again is an infinitesimally small amount of time, but because we're working with the speed of sound, we need to be very quick with these things. So then we need to switch that off, so we send it a low. Okay, and now what we need to do is read that in, so reads the echo pin, return the sound wave travel time in microseconds. Okay, so what we say here is duration equals, and then there's a command called pulse in, and we give it the echo pin, and we are going to make that high. And again, that's essentially going to tell the echo pin to capture the sound coming back and to tell us how long that took. So what we need to now do is calculate the distance. So distance equals the duration times by 0.034 divided by 2. Now if you remember, that 0.034 is to do with our speed of sound. If I just get that animation up, let's wait for that to do its thing. So back on the other screen there, we can see that the speed of sound is 3,440 centimeters per second, but we're working in microseconds, so it's a different number that we're using there. We're essentially just timesing it by how many microseconds are there in a second? Google is our friend. There is 100,000. What's that? Is that a million? That's a million. Yeah, a million microseconds in a second. So that's why it's a slightly different number there. Okay, let's go back to our Raspberry Pi. And the divided by 2 again is because of the distance. We want it to go to the waveform and to the object and back again, and therefore it's twice the distance is what is being returned, and what we need to do is just divide that by 2 to get the actual distance of the object. So that is the code for calculating the range. So what we need to do now is just write that out. So serial.print, and we will say distance and serial.print distance and serial.print line, and then space centimeters. So a couple of things here I figured out as well. On the last live stream that we did, I was having some problems when I was trying to write a string to the serial monitor and it was returning a number. And unlike normal C, where you can interchangeably use speech marks and the single quote marks, on Arduinos you have to use speech marks. You can see it turns blue there. And that's just one of the things I didn't know and I've now found out. So this will now make it work the way we intend it to. So if I just verify that to make sure there's no problems. So there is a problem, it's not happy with that. Let's just have a quick look and see what's going on there. So we've not defined trig, that's what it's saying there. Because it's not called trig, it's called trig pin. Just missed off the pin off the end of that. Let's just try that again. So it's not happy with that, and that's because I've done a typo. There we go. Try again. Oh, I've got quite a few bugs in this one. So what's it? Not happy with that one. I've not put the semicolon on the line before. Try again. And there we go. This is why I thought I would actually code this live so you can actually see the kind of mistakes and how to go about fixing these up. So the other thing I just wanted to say there is we've got serial print and serial print line. So print will put those characters onto the line, but it doesn't do a new line and return back to the beginning. So that's why if you do distance as a print and then the variable distance after it, it will be on the same line, but then print line puts at the end of that a new line. So it'll print it to the screen and then return to the next line. So if we open up our, I think have we uploaded that to our robot? You can just see that flashing now. Yep. Now if we go to our serial monitor, we can see there it's reporting back distances. Now if I put my hand in front of this and start moving it towards it, you can see there that it's detecting the distance of my hand. So because my hand's not completely flat, that's probably why it's having a bit of an issue with that. Let's see if there's something more flat that we can bounce the signal off. Let's try that. There we go. So if I just split the screen, we can see what's going on. So there we go. I'm moving that more and more towards the SMARS, and it's going 3, 2, 1. And if I move that back again, we can see that's also increasing in distance. So that is quite accurate. I've measured this before with a ruler to see how accurate it is, and it's pretty spot on. There we go, so that's working fine. That's all good. So we'll just close that serial monitor. I'll just jump back to the full screen Raspberry Pi and just close that out for a second. And what we'll do is we'll create a new program now, and we'll create an avoid. So we'll merge in the code that we created on the last live stream, where we made the robot go backwards and forwards depending on what character we put in. And we'll modify the main loop slightly so that we can make it go forward unless it detects an object in front of it, and then it will do something, either turn left, turn right, or so on. So let's just have a quick look and see on the live stream how things are going. See, we've got Tom on there. Hi Tom, hope you're having a good evening. Okay, so let's go to our lessons on here. So I've also stored the lessons on GitHub. So if you go to my user account on GitHub, so github.com/KevinMcAleer, lesson 1, 2 and 3 are all on there. So if we grab the code from lesson 2, so I just jump on here, find the repository for lesson 2. Lesson 2, turning, there we go. And that's also available on the SMARS fan website as lesson 2 as well. And there we go, we've got some code there we can just quickly pinch. So this is what we did, not yesterday, the day before on Sunday evening. I'm just going to grab all that. And let's paste that into our new sketch. There we go. And let's just save that. And we'll call this one avoid. Okay. So let's just make this full screen so we can see what we're doing. So just quick look through this. So this was the setting up the motors, setting up the serial, setting up the motor outputs, and then the code for forward, backwards, left, right, and then the main loop. So what we need to do at the very top here is bring in the code from our rangefinder that we've just created for these echo pins and the duration and distance. So if we just copy those couple of lines there and paste that into the very top section here, we can do that just here. And then the next thing we need to do is change that line at the bottom. So all this code here about reading in, we can get rid of all this now. So let's just highlight that and delete all that. So what we're going to say instead, we're going to do a very small function here. So while true, execute this code. So that'll essentially run forever. And what we're saying is we want to go forward, and we want to then take a measurement. So what we'll do on our rangefinder code, that main loop that we've got down here, we'll put this into a function that we'll call ping. So we can essentially do a ping and have it return back the distance. So if we just grab all this code here, there we go, and we copy that and we paste that into the other one. And what we'll do, just above the main loop, we'll create a new function. Sorry, this isn't JavaScript, this is right, void, and we'll call this one ping, and we will paste in all that code there. But where I've got void, I'm actually going to change that back to an int, because what it's going to do is it's going to return, let's put a little note up here, returns the distance of the ping. Okay, so it does all that, and at the very end where we've got the distance, what we just need to do there is just say return distance, and that will return to that little int there the distance that is found. So what we can say now, before our forward, we can say ping, let's create a new variable that we're just going to call n. So n equals ping if n is less than, should we say is less than, is greater than, it's greater than 5 centimeters, then that's fine, carry about your business. So therefore move forward. Else, what we'll say now is, otherwise what we want you to do is turn left. Okay, let's just compile that and see what happens. So what have I missed out there? It's just one of them missing from that. Let's just compile that again. True is not defined as in scope. Is it lowercase? Yes. Verify. I've been doing some Python coding. They have a capital T in Python. Right, there we go. So if we now upload that and we switch back over to our split screen, we can see that our SMARS is going backwards. Now let's see if I put an object in front of it. Well, actually it's trying to turn left there, I suspect. So to see what's going on in its little brain there, let's go to the monitor and see what it's telling us. So there's nothing going on there, I think, distance wise. That makes me think the code's not right. So let's have a look at our ping and see what's going on there. Okay, bear with a second. Okay, so I've got a one I made earlier just to quickly check to see what's going on there. Let's make sure we've got something similar there. Okay, so that's our avoid, that's the other one. So what I've done on the other code there, you can see I've kind of got it the other way around. So rather than saying if it's greater than 5, I said if it's less than 10. It doesn't really matter which way we do it, which way we decide to have the code. What we do need to have in there though is a delay. So we've not got a delay for either of them, so we just need that actually, yeah, after that command there. So delay, I'm going to say 100, and similarly after that forward there we need a delay as well. Do that first of all. Let's upload that, see if that makes any difference. Let's check our monitor. Oh, so it still thinks our distance is not correct. So let's just have a quick look through that ping thing to see what we're doing wrong there. So that looks exactly the same to me, that should work. And then our main loop, we have dist. So let's do that. Let's, instead of calling it n, it's good practice really to name the variables something meaningful rather than just a letter for speed. So let's do something similar to what we've got in our other one. So let's say less than 10, then let's cut that out. Now let's actually write a message to the serial saying that we've found an object. Object detected, and then on this version we're going to say first of all we want you to move backwards, then we want you to turn left, and when I was experimenting with these it required more than one turn left to make it actually turn enough. Okay, and then this last one here, otherwise go forward. Okay, I think they all need, do they need a delay? Maybe not, maybe that's fine. I don't see why that would make any difference to the code and the ping. Just make sure everything's good. That sounds much better. Let's go back to our split screen and let's have a look what's going on the serial monitor. Just switch back to full screen for a second so we can see what we're doing. There we go, that's what I was looking for. So it keeps thinking there's an object detected. Now, why is that? So I think what we need to do as well is echo out constantly what the distance is, so we can see. It might just be that it's detecting the camera or this lamp that's next to it. Okay, so let's quickly change our code. I'll tell you what I'll do. I'll just upload the rangefinder one just to make sure everything's still working, just in case the wires come out or something like that. Okay, so we can see now on the serial port that now is working properly. I'm putting my hand in the way. I'll go back to our split screen, that's SMARS cam. I'm putting my hand in the way there, and I can see that the distance is changing. And if I move it completely away, you can see there that it's detecting nothing for 2 meters or so. Okay, so let's go back to our avoid code. Let's upload that again. Okay, let's see what's going on there. Let's go full screen on the Raspberry Pi for a second. There we go. So it keeps thinking that there's an object there, and we know that there isn't really, so that must mean there's something wrong with our code. Let's have a quick look through that again. So we're saying if the distance is less than 10, then say that. So what is distance? Let's actually print out what the distance is. Serial.print line distance is not sure if we can do this, but we'll give it a go. Let's try that. Oh, it's dist, not distance. Okay. Okay, let's just change that to 2 lines. It doesn't seem to like me doing it that way. So serial.print and we'll just get rid of that bit at the end. There we go. Let's compile that. Let's upload that, and then let's see in our monitor what's going on. So it thinks the distance is 0. That suggests to me that it's not passing this variable backwards and forwards properly. So we're initializing, so maybe we should do that just outside of the loop. So let's say int dist equals 0. And then we're saying dist equals ping. And that's what we've got in our other code there. And then we're then looking at that and saying if that's less than 10, then do something. Okay, let's upload that. So I've clearly got a bug in the code there somewhere. This is the version that I've uploaded to the tutorial that I've tested out. So I must have something wrong within one of the lines somewhere, because you can see if I go to the split screen, go to SMARS cam. So that's moving forward quite nicely there. If we then introduce an object and start moving that closer and closer, you can see that it's now turning to the left. To the left hand wheel is going backwards, the right hand wheel is going forwards, and that would turn the SMARS round. And then if I move that again, he's going to carry on going forwards. There we go, so that's working perfectly there. So I have had these roaming around. I posted a video up on YouTube and Facebook and Instagram yesterday of two SMARS smashing into each other. One of the SMARS had this is a slow motor, so I think they're 150 RPM. The other one I think was about 300 RPM, so they're ridiculously fast, a bit too fast, and it managed to shred its tracks. Whereas this one, because it's got a lot of torque, when I had them go head to head, this one won. This one won the battle because it's very, very strong motor. So this can climb over anything. It's just a bit slower. So again, we can see that that's going to go to the left. Oh, it's going to carry on going forwards. There we go. Okay, so that is the code there. So let's have a very quick last look and see, can we spot the bug? I'm never satisfied when I'm showing somebody and then it doesn't work, so let's just try and see if we can very quickly debug what is going on here. So let's start at the very top. So I'm just looking through there, that's the same. When we set up our setup, everything's fine. Aha! We've not set up the trigger pins, that's what's gone on. So if I copy those over, put them in our setup, that's why it was returning a value of 0 when it was doing the measurement. It didn't understand what the pins were, they hadn't been set up correctly. So I bet if I now upload that, it'll have the same behaviour. I do think the code that we've used before, oh, that's working fine now, yep. So if I now do that, it's going to go backwards and then go to the right. So it's a slightly different algorithm, this one. So you can see there, it's going forwards. Let's go to split screen so we can see what's going on. Oh, we'll go to the SMARS cam actually. So it's going forwards, you can see both tracks there rotating in the same direction. We then put something in front of it. You can see that it's going to go right and then backwards. So that's a slightly different algorithm that we've used before. It's going forwards, goes backwards and then turns to the left, I think actually. So we'll just put in an object in front of it and letting it carry on. There we go. Perfect. I'm pleased we found that bug. I don't like to leave, especially when we're doing a tutorial on that, to actually have an issue like that. Okay. So let's have a look what else we've got to go through. Okay, so I'm just going to jump back to me there. Okay, so if I jump to this smarsfan.com website and we go to the Learn and then Video section, we can see the show schedule. And so we've done the sensors one today. We did just cover the rangefinder sensor. I do intend to look at maybe some other sensors such as the temperature, the light and humidity and so on. Is it the DHT 1122? I think it is. And things like the light sensors as well. So there's quite a few different sensors that we can actually play around with, but really for the SMARS robot, the main sensor is the rangefinder. That's the most practical for the robot. But what we now have, after a couple of lessons of this, he's going to decide to do one now. SMARS has just decided to jump off his little plinth and roam around the desk. It's going to unplug him. There we go. Okay, so yes, so after a couple of these live streams, we've now got fully printed 3D robot. We've got an Arduino that we put in there. We've got the motors wired up. We've got the rangefinder. We've got the tracks and the wheels. We've got some code to move it forward. We understand how that code works. We understand how to do a rangefinder and how to ping signals back and forwards with that. And then we've also then looked at how we can enable a robot to use that rangefinder and algorithms to move left and right. So quite a few things that we've looked at there. So next is going to be looking at positioning. So this is using some little chips that you can buy that similar to an iPhone or an Android phone, that can detect the orientation of the device in 3D space. So it can give you a reading of whether you're facing true north, magnetic north, whether you're planar, whether you're pitching, you're in rolling, and so on. And it can give you figures on that. So that means that we can then look at, from a SMARS point of view, and see how far have we turned 90 degrees or not. We can look at things like that with positioning. The lesson after that will be Bluetooth and serial communications. So we've done a little bit of serial comms there, but we'll have a bit more of a deeper dive into that. And the Bluetooth, we'll look at how we can use Bluetooth modules to enable a bit more remote control. So rather than the robot doing its own thing, we can make it more like a remote control car, and we can control it from an app. Or from another computer, and maybe we can have more than one of these, and we can have a bit of a race. And then we can look at servos. So the walking SMARS, the quad, that has servos. If we go back to our split screen view there as well, that little Otto DIY that's sat at the back there, I'll just put him on here for a second. I know this is SMARS fan, but I do also like these as well. He's got a couple of servos in there. I think there's 4 servos, 2 for each leg. So we'll be looking at how we can use servos and what we can do with them. That's all about pulse width modulation and angles. After that, we can look at the line following. So there's a little module that you can get for line following. If I just duplicate this tab, and we have a look at the learn section and electronics. And let's have a look at the line follow module. So that's what they look like. If I just jump back to the host view, there you go. That's the line following module on smarsfan.com. So I went to the learn section, electronics, and then line follow, and you can see there that's what they look like. They've got 2 little, similar to the rangefinder. There is a sender and a receiver essentially, and a little analog pot there you can twist to make it more or less sensitive, and you've got a couple of pins out there as well. So similar to the rangefinder, there'll be an echo and a trigger type pin, voltage and ground, and we'll be able to use that to follow a line, or you can use masking tape on the floor, and the SMARS will sort of follow that round. So that's quite fun to do as well. So that's what we'll be looking at in the line following one. And then I thought on one of the last ones we'll look at things like wireless charging. So that's it for today. Please like and subscribe to the channel. It really does help me out if you like and subscribe and comment on the channel as well. Makes me understand if you are getting good value from this, if you find it interesting, and also sort of encourages me to do more, the vanity metrics of YouTube. So yeah, the next week's show is on Thursday. So not next week. Next show is on Thursday, and that'll be about positioning. Yeah, please check out the website. Make sure you can see all the new things that are going on there. And if you're not part of the SMARS fan community, if you're joining from YouTube and you're not part of the Facebook community on the SMARS Facebook community, please join that as well. It's a really vibrant team of people there, all dedicated to all things SMARS. So great, thank you very much for your time and your interest in this, and I shall see you very soon. Thanks everybody.